Hello guys, here Mr. G with another video for the grade 12. This time we're going to be working with organic chemistry. We're going to go all the way back and do a question on organic chemistry. Remember, this topic is quite important. It's going to be in the junior examination and in all the examinations up until the end of the year. This time we're going to be solving question 2 from the question paper of 2016 done at the Northern Cape at the Free State. But before we carry on, please subscribe for the channel so you can get all the notifications and videos I post on regular basis. This question say a letter A to F in the table below represents 6 organic compounds with different functional group, and the question 2.1 define the term functional group. And we have that the functional group is a bond or an atom or a group of atoms that determine the physical and chemical properties of the compounds. That is what we call functional group. Okay, you have to learn the definition. It's a very high probability of being in the exams. Question 2.2.1 write down the letter that represents a carboxylic acid. Now guys, before we go on, let's quickly write down here the homologous series of each of these compounds. And we're going to start with the first one. The first one, the functional group, you can see is this O with a carbon and a hydrogen which is bound to another carbon, and this is therefore an aldehyde. That is an aldehyde. B, we can see here the double bond carbon to carbon, and all of it are carbon and hydrogen atoms, therefore is a alkene. We're going to compound C, and we have the COOH. If it's in a condensed formula, this one is a carboxylic acid. If we go to compound D, we have the molecular formula of a compound which is 2 carbon, guys, and there are only 2. They are esters or carboxylic acid. This one is an ester or could also be a carboxylic acid. Could be an ester or carboxylic acid, but esters, carboxylic acid generally are written like that one there with COOH. Question, compound E, it ends in on, and therefore it is a ketone. And the final one, compound F, it ends in ine, as you can see there, and therefore it is a alkyne. It is an alkyne, guys. We have now the homologous series of all the compounds. So now it's going to be quite easy to answer this question here. I have a video on all the homologous series and functional group. I leave the link right here. Now here a question 2.2.2, the letter, the first one, 2.2.1, the letter that represents a carboxylic acid, guys, we identify is going to be C. Question 2.2.2, IUPAC name of compound A. So we have to write the name of compound A, and this one is quite simple. Now there are steps to name compound, but remember this one is an aldehyde, and the first step is going to end in al. Alright, second, you have to look for the longest continuous carbon chain that have the functional group. This one have only one carbon chain there, which is this one here. Is have 1, 2, 3, and 4, and is but but because it's an aldehyde, then you have to say butane. And then you look for branches, which is the case. There is not any branch here, guys. So in this compound, the name is going to be butanal altogether. This is the name of the compound for this compound A. So it's going to be butanal. Write the name of compound B. Now compound B, we are going here to this compound, and there is a little bit more tricky here. So let's go to another page. Alright, so here we have the compound, and we're going to follow the steps I like to follow. The first one is to identify, and we did already that one, guys. It is here, it is an alkene, and because it's an alkene, then it's going to be ending in That is the first important thing. Let's write it just here in case we forget. There is alkene. Now the second step is to look for the longest continuous carbon chain that has the functional group. Okay, so what options we have here? We can go all the way starting from here, go back and turn, and I think it's going to be the longest one. In that case, we have 1, 2, 3, 4, and 5 carbons, and then we have this one here, which is 1, 2, 3, and 4. So 5 is the longest one, and then 5 is a pent. 5 is pent. Okay, so now what we are going to do, we are going to count the carbons starting from the nearest to the functional group. Okay, so if we starting from the right, this is carbon 1, 2, 3, 4, and 5. The double bond is in carbon 2, as you can see there. If you starting from top, you always have to make sure you have both probabilities. 1, 2, so it's going to be further away 3, it's going to be in carbon 3. Therefore, we're using the blue one. 1 and 2, no. So now here, we are going to come and we're going to add the place where the double bond is allocated there, which is in carbon 2. So it's 2 in, guys. Now, what else you are going to do right now? You are going to look for any branch or any substituent. In this case, we have here 1. You can see it here. This is a substituent, which is a alkyl group and it's a methyl. This one here is a methyl. And that methyl is in carbon 3, guys. So we are going to write it here. We have a 3 methyl. And that is all we have in this compound. So there we are going to write now the name, which is the combination of all this. So what the name is going to be? 3-methyl pent together dash 2-in. And guys, this is the name of compound B. That is the answer for compound B. Okay, so we can carry on. Write down the homologous series to which compound E belong, and we did find out the homologous series of all of them. So that one is going to be a ketone. Ketone, there we go. Now, structural formula of compound F. Now you have to take compound F right here, which is an alkyne, and make sure you write the structural formula. So we are going to do that one is possible in a new page. It's not space here. And here we are. The compound is 2,2,5 trimethyl hept 3i. Now, when you're writing the functional, the structural isomer, we're going to start from hept. In other words, the number of carbon in the longest continuous carbon chain. Hept means 7, and then you're going to have 1, 2, 3, 4, 5, 6, and 7 carbon on a straight line. That is the important thing. And obvious, I'm going to start from the left, 1, 2, and 3. So in carbon 3, now in carbon 3, you have the triple bond. Remember, we said it's going to be an alkyne, but let's write it here anyway. Alkyne, and that is going to be in carbon 3. All right, so 1, 2, and 3. Here you are going to have the triple bond. In carbon 3, you will have the triple bond. Now we are going to look for the substituents. In carbon 2, there is 2 methyls plus in carbon 5. So I'm going to have here, this is carbon 1. In carbon 2, I'm going to have 1 methyl CH3, but it must be everything in structural formula. And there's another methyl in carbon 2. Okay, there is in carbon 2 methyls there, as you can see, and then the other one is in carbon 5. 1, 2, 3, 4, and 5 is another methyl. It doesn't matter if you do it either top or bottom, it does not really affect anything. Guys, the rest is to complete the compound. Now, be careful. I always leave that single bond between carbon for last, which is what I'm going to do now. And now be careful, make sure every carbon have 4 bonds. The first one is 1 hydrogen, 2 hydrogen, and 3 hydrogen. So it's 1, 2, 3, and 4 with the other carbon. The second carbon already have 4 bonds. The third carbon already has 4 bonds, as well as the fourth carbon. And then this one needs another hydrogen, and guys, this one is quite simple, the rest of the compound. So this one was the structural formula of the compound that they gave you. I hope you understand, it's not that bad. So we almost done here. Question 2.3, for compound D, write down the structural formula of each functional isomer. Now be careful with this one. Compound D is a ester. We said a compound D is an ester. You have to write the functional group. For compound D, write down the structural formula of each functional group. There we go. Structural formula of the functional group. It is an ester. Therefore, the functional group of an ester, I'm going to write it right there on this side here. It's going to be a carbon with double bond oxygen. This one is going to be another carbon, and this one is going to be oxygen carbon. All right, let's maybe do it on the other direction. This one is oxygen carbon, and this one here doesn't need to be carbon. There we go. That is the functional group of a ester. That is the functional group of the ester. You know, it's very easy to forget because this one was done quite long ago, and you forget very easy. So it's the functional group what they want, structural formula of each functional group, and the functional isomer. So we are dealing here with an ester of 2 carbon. The ester with 2 carbon. Now they want the functional isomer, and I want you to take note here. The functional isomer of an ester is going to be a carboxylic acid. So we are looking for a carboxylic acid that has the same molecular formula of 2 carbons as it is here. 2 carbons, we need now 4 hydrogens, and we need 2 oxygen. That is the ester that they give us. We're looking for a carboxylic acid, which is the structural formula. As you can also see, they want the structural formula, no in other way. So guys, it's quite simple. We're going to convert this one into an acid, into a carboxylic acid, okay, which is not that case there, because that one have only 1 carbon. You can see that C have only 1 carbon, so it cannot be the functional isomer. The functional isomer must have the same number of everything. So guys, it's quite simple. We're going to first start with the functional group, which is a carbon, double bond oxygen, and then single bond oxygen hydrogen. That is the functional group of the carboxylic acid, and we have to adjust 1 carbon here with the hydrogen there. Guys, this one is the functional isomer of the structural formula of the functional isomer of that specific ester there. This one is a carboxylic acid. It's a carboxylic acid. And guys, this is the end of this question 2. I hope it helped, and I hope you understand what is going on here. But please subscribe for the channel for the next videos that I will be posting, and I'll see you next time. Mr. G here.